In this video, I'm going to quickly go over the week 6 lab, which covers confidence intervals. Here is how you will be graded on the lab. So confidence intervals were the main topic in week 5. So let me pull up the week 5 lesson really quick. This lesson is a great place to start if you have some questions still about confidence intervals. And hopefully you've been using this spreadsheet quite a bit. It's demonstrated in a video at the bottom. It helps with all the computations and calculations that go along with confidence intervals. So jumping back into the lab, I'm going to quickly talk about what you're supposed to do. And then I'll also do a little video demonstration of confidence intervals so you have that piece as well to help better understand what they are and how we use them. So the first thing you'll want to do is read these two articles. They're 1 page long each, so they don't take long, and they give a very good, some very good examples of how confidence intervals can be used in the health science field. So click on them, and they'll take you directly to the article, but you need to click on full PDF, and it could be hidden. If it's hidden over here, just click the arrows. You need the full PDF, PDF full text. And then the whole article will pop up. And like I said, it's just a 1 page long, and it's a good read about confidence intervals. So really what you're doing in this lab is coming up with your own example of a scenario or situation where a confidence interval could be used to help make a decision or solve a problem. So you're going to start off with just describing that decision or problem. And then part B is how would the interval help solve that problem or help make that decision, and also what level of confidence would be the most appropriate and why. And I'll talk more about this as I do a video demonstration of confidence intervals. But in a nutshell, as the confidence level goes up, the interval gets wider and less precise. As confidence level goes down, the interval is narrower and more precise. And then in part C, in order to gather your sample and create your confidence interval, what data would need to be collected, and what's one way you could go about collecting that data, ideally with a good random sample. And when you're done answering those questions, make sure your name is on your document and then upload it. And let me know if you get questions or stuck anywhere along the way. And so the rest of this video, I'm going to do a quick little talk through of confidence intervals and what they mean. So for this confidence interval example, we're going to be talking about the average days until full recovery from, I'm not going to be specific here, but just some disease or injury or surgery. And we want to know what the average is for the entire population. If we were able to look at every single person, and we'll just make our population everybody in the world. If we were able to look at every single person in the world, what would be the average days until they fully recover from this scenario? And so we can't get data on every single person. Instead, we have to take a sample and use that sample data to try to estimate what the mean is, what the average is for the entire population. So let's go out, gather a good random sample of people. Since I'm using everybody in the whole world, a good random sample would need to include people from every ethnicity, all around the globe, different countries, and I'll get a good random sample. And what I'm going to do then is I'm going to look at that sample, and I'm going to get what the average is for that particular sample. And let's say it comes back really close to 80. So my sample came back with an average of 80. Now I don't just want to guess a single number for what the population average is, because it's very unreasonable to think that my one number guess is actually going to be correct and that my sample was absolutely exactly like the entire population. So what we do instead then is we build a confidence interval. And I'm not going to go into the mathematics of it here, but we use the precise computations to get a range of numbers that we are confident the population mean really lies within. And the mean from our sample is always right in the middle. So if my lower bound is 3 below the sample mean, my upper bound is going to be 3 above the sample mean. So we're just assuming that my sample data came back with a mean of 80, and my confidence interval computations came out that we are confident that the real population mean is somewhere between 77 and 83. We don't know what number it is in that interval, but we're confident it is in there. And we'll always have a level of confidence, and this level of confidence is tied into how wide our interval will be. A common one's 95%. What that 95% means is if I got 100 people to go out and do the same thing I just did and gather a sample from around the world, a random sample of people, we would all get 100 different samples because we would have different people in our sample. And our 100 different samples would have different means. And so somebody else might get a confidence interval that's over here. Somebody else might have one that's a bad color to use, that's close to the sample I got. But we'd all have these confidence intervals that have different because they're based off of different samples, they'd have different sample means, and then they'd have different ranges that we're confident that the real population mean lies somewhere in between our confidence interval. So what this 95% means is that out of those 100 different intervals that we come up with, 95 out of 100 will actually contain the real population mean. So wherever the real population mean falls on this number line, whatever the average days until full recovery is for everybody, it's going to be in 95 out of 100 of the confidence intervals we created for 95% confidence. And so one last thing I want to touch on in this video is if we up this to 99% confident, well, how do we get more confident? Well, the math, the computations behind the scenes, what that's doing, and I'm trying to erase these here, we're getting more confident because we include more numbers. So the interval would get wider. And so the computations to get 99% confident makes it wider spread out interval around our sample mean. So this should make sense. Of course, you're more confident if you have more numbers that you're including for what the possible real population mean of everybody is. And then likewise, if we went down to a lower level of confidence, let's say we're only 90% confident, that's because we get narrower confidence intervals. So the computations for a 90% confidence interval produce an interval that's a little bit smaller. And that smaller interval is more precise. There's less range here, so we can say that there's less numbers that are possibly in here. That can be useful sometimes to have a smaller, more precise range, but you're less confident in it. Out of 100 people creating out of 100 different samples, 10 of them will not contain the true population mean instead of just 5 of them at 95% or just 1 of them at 99%. So there's a trade-off here. Do you want to be more precise with this smaller range of numbers? You can say something a little more precise and definite about the population value, but there's more chance that you're wrong, that it really doesn't fall in that interval. Or is it better to really make sure that you have an interval that it is within, and the trade-off is here that your interval is a little wider and contains more numbers and is less precise. So how could this particular example be used to help make a decision or solve a problem? Well, it would be useful to know the average days until full recovery if you're giving that outpatient information to the patient about how long they should expect before they're fully back to normal. And so you would want to know a range so that you can give them precise information so they can plan for their work and their social life and just for how long they'll need to keep checking in at the hospital or taking medicine or whatever until they're fully recovered. And there's really no wrong or right answer here for what level of confidence would be most useful. I think personally it would be nice to have an interval that really does contain the true average. So I would go with a higher level of confidence. And so there is more of a variation there. The patient's not going to know a more precise or exact number, but everyone's recovery is a little different anyway. Some are going to be close to the population average, some will be above or below anyway. So giving them that wide range of data that you're really confident the population average falls in between, I think that would be helpful for them to know how long to expect until they're fully recovered. So reach out if you have any questions still after this video. I'll be happy to help more with the week 6 lab or anything else that you're having questions about.